Hi, my name is Angel Feyh Bsce from Bsce 2C. So the problem is, if the supplied force F is equals to 150 Newton, determine the velocity of the 50 kg block A when it has risen 3 meters starting from rest. So the problem comes from Engineering, Mechanics, and Dynamics, 14th edition by Russell C. Hibbeler. So for this problem, if we wanted to know the acceleration at B, then we can use kinematics. But in this particular case, we just been asked to find the velocity of A, which we can find directly by just finding the tension in the cables. And later on, we use the equation of motion. So let's just do a section here and here. So in the figure, since the pulley are smooth, the tension is constant throughout each entire cable. So referring to the FBD of the pulley, of which its mass is negligible. So first, we consider the free body diagram of pulley C, and as we can see, this force F is equals to 150 Newton. So this cable or this rope is continuous. So we will have 150 tension in this complete rope, and this means that we will have the same tension force here, which is 150 Newton. So since it's one rope or one continuous row, and let's say that in this cable we have tension or T. So since the mass of the pulley is negligible, this is equals to 0. So the summation forces along Y for this pulley C is equals to 0. And as we can see, if this is acting positive Y direction, this is 150. And plus 150 minus T, which is acting downward, so the T is equals to 300 Newton. And in this figure, we can consider that in this pulley, where the mass is attached and which the block is attached to. So in this free body diagram, we know that the tension here is 300 Newton. So this will be 300 Newton and 300 Newton. And the height of this block A will be acting vertically downward. And the mass is 50 kilograms, so 50 times 9.81, and the block A will be accelerating. And again, we apply the summation forces along Y, and since the mass of the pulley is negligible, then it is equals to 0. And as we can see, the force 300 Newton is acting in a positive Y direction. So for this, 300 plus 300 minus 50 times 9.81 is equals to 50A. We get 2.19 meter per second squared. And the positive signs indicate that block A is accelerating upward direction. And now we are given that the initial velocity is 0 or start from rest, and it travels a distance of 3 meters, and initially let's say that the position of block is 0 meters. So V squared is equals to the initial velocity squared plus 2ACS. So V squared is equals to 0 squared plus 2 times 2.19 times 3. So V is equals to the square root of 0 squared plus 2 times 2.19 times 3. So V is equals to 3.6249 meter per second or 3.62 meter per second. So the final velocity of block A is 3.62 meter per second.